In theoretical probability distribution, in last video we have discussed what is Poisson distribution and where we will use the Poisson distribution is over there. When the probability of a event is very low for happening and probability for not happening that event is very high, then we will use Poisson distribution. Already we have discussed this. Suppose the probability of an event is 0.001 and probability of not happening event is 0.999 or approx 1, then we will use Poisson distribution. In last video we have discussed this. So Poisson distribution is very important distribution is over there. When you will feel, जब भी Poisson distribution उस समय काम में आता है जब किसी भी घटना के घटने की प्रायिकता बहुत ही कम और घटना के नहीं घटने की प्रायिकता बहुत ज़्यादा हो, लगभग 1 के बराबर हो, अप्रोक्सीमेटली इफ probability of not happening is approximately 1, then we will use Poisson distribution. Later we have discussed the formula for the Poisson distribution. Also we have discussed that formula for the Poisson distribution is n e raised to power m raised to power x divided by factorial x. We will use this formula for calculating Poisson distribution. Here the value of m is equal to sigma x bar is equal to sigma fx upon sigma f or equal to np. So for calculating arithmetic mean of Poisson distribution, we will use x bar may be sigma fx divided by sigma f, or we can use that is np as we have used in binomial distribution. So in today's question we will having two questions related to the Poisson distribution. Then in next video we will having discussion on the constant value of the Poisson distribution. So having this, we are having questions. The very first question related to the Poisson distribution. Suppose I am having one question related to the Poisson distribution. Fit a Poisson distribution to the following Poisson distribution. The data is given. The question is fit a Poisson distribution to the following data and also calculate the theoretical frequency. Here the data is given, x data is given, value of x, that is 0 to 4, 0, 1, 2, 3, 4. Frequency of the data is given 122, 60, 15, 2 and 1. Here the data is given. So firstly learn the data. In Indian Punjab regiment, the number of in last 200 years, the number of soldiers who are having death due to fall from the horses, the data is given. Againly I am repeating the question. In Punjab regiment of Indian Army, the soldiers who got dead due to fall from the horse riding, in last 200 years, 0 death in 122 years, 1 death in 60 years, 2 death in 15 years, 3 death in 2 years, 4 death in 1 year. So fit a Poisson distribution and calculate the estimated frequency for that. We have to calculate the estimated frequency for the same is over there. In this we will calculate the estimated frequency. So the very first m is equal to sigma fx divided by sigma f. For getting this we calculate fx, that is 0, that is 60, that is 30, that is 6, that is 4. So this is 100. So m value is equal to 100 divided by 200. Sigma fx value is 100, sigma f value is 200. So the m value is 0.5. Okay. For Poisson distribution, we want e raised to power minus m, and this is reciprocal antilog 0.4343 multiplied by m. We have, in last video we have calculated that for calculating e raised to power minus m, we will use the formula reciprocal antilog 0.4343 multiplied by m. For getting this reciprocal antilog 0.4343 multiplied by 0.5, m value is over there. So this is reciprocal antilog. We will multiply with 0.4343 with 0.5. So 0.4343 multiply 0.5. So 0.2171. 0.2171 is okay. So getting the antilog of this, here is 0, so 1 point. We are to see the antilog table for 0.21 and difference is 7. So the very first we will see, we have to see the antilog table. So firstly, in your book, in last, there is a table is over there. One is Lagrange's table and second one is, this is called anti-Lagrange's table is over there. So in this anti-Lagrange's table, we will see 21 at the difference of 7. So here the 21 difference of 7 is given 1608. So I have taken this. This is given 0.21, there 1648 and the difference is 0. So there will be 16.4. So the value will be 1648 and we are having 0, so point will be here. So we will get reciprocal, there will be 1.1648. So 1648, so this value will be 1 divided by 1.648, that is 0.601607. And this value in also given e raised to power minus 0.5, we are having e raised to power minus 0.5. We are having the value of this also in e raised to power minus m, that is e raised to power minus 0.5, that is 606. This is also having this e raised to power minus m table is over there. We will see 0.5 at the 0, that is 0.606. Here also we are getting 606. 0.606. So the very first you learn, what we will do, firstly we will get the arithmetic mean of this, that is 0.5. For getting e raised to power minus 0.5, the value, m value is 0.5. So that is reciprocal antilog 0.4343 multiplied by m. We have put the value of 0.5, multiply this, that is 0.217. Now we have seen the antilog 0.221 up to 7, that is 1648 and the difference for 1 is 0. So this will be 1648 and here is 0, so the point will be after 1. So 1.648. Getting the reciprocal of x is equal to 1 upon x. So the reciprocal of 1.648 will be 1 upon 1.648. So we are getting 0.606. And if we see the table of e raised to power minus m, there also we get 0.06. So you can having the directly you can having the value of e raised to power minus m with the help of the e raised to power minus m table, which is given in your tabulations, statistical tables. You will give the value of e raised to power minus m. As I have showed you that there should be the value of e raised to power minus m. This value will be available. You have to see 0.5, that is 0.6065 is over there. Okay. Now we have calculated now what we are to do for the estimated frequency. The very first we have calculated the e raised to power minus m. We can having the direct from this. In question also this is given, but how to calculate this e raised to power minus m? I have given the methods for calculating e raised to power minus m. If you don't want to do, no problem at all, you can direct seeing in examinations. If in question they have given that e raised to power minus m value is 0.606, so then we don't want to doing so, हमको ऐसा करने की ज़रूरत नहीं है, सीधा ही हम उसमें काम करेंगे. अब देखिए हमारा जो फॉर्मूला ई पी एक्स इजिकल टू एन ई रेज टू पावर माइनस एम raised to power x divided by x. This is our value. And e raised to power minus 5, that is given 606. So px is equal to 0. So here n is equal to 200, total number. Multiply this one is 0.606 multiply 0.5, m value is 0.5. Power 0 divided by 0, so the very first will be 200 multiply 0.606. So the first value will be so 121.2 or we will write 121 first value. So this is estimated x बराबर 1. So then 200 multiply 6.606 multiply 0.5 raised to power 1 factorial 1. So there will be 200 multiply 0.606 multiply 0.5. So we will having the multiplication with 0.5 to this value. So 60.6. This is 60.6 or we having 61. Now estimated frequency for x is equal to 2, that is 200 plus 0.606 multiply 0.5 raised to power 2 divided by under root 2. So this is calculating 200 multiply 0.606 multiply 0.25 upon 2. So the value of multiply by 0.5 divided by 2, so 15.15. So that is 15.15 or we will write here 15. So third value is 15. And last one x is equal to 3 for that 200 plus 0.606 multiply 0.5 raised to power 3 upon factorial 3, that is 200 multiply 0.606 multiply 0.125 divided by 6, that is 2.52 or we will write here 3. And last one p x raised to x is equal to 4, that is 200 0.606 multiply 0.5 raised to power 4 divided by factorial 4, that is 200 multiply 0.606 multiply 0.625 divided by 24. 0.125 or we will write here 0. So the estimated frequency we have calculated. First one is 121, second one is 61, third one is also 15, and this is 3 and this is 0. So the total of this is 5 plus 3 plus 1, that is 200. So with the help of the Poisson distribution, we can calculate the estimated frequency. If we want to calculate the chi-square test is also. So we are having original frequency, we are having estimated frequency. On behalf of original and estimated, we can calculate the chi-square test also. Okay. So in this manner, we can having the Poisson distribution. We are having one more question related to the same. हम एक क्वेश्चन और करते हैं Poisson distribution का, ताकि आपको बहुत अच्छी तरीके से क्लियर हो जाए कि how to calculate the Poisson distribution is over there. One more question that is repeating in the examination. I am taking that question. The table is showing number of deaths on the horse kicks age per crop per year in 10 precision army cap during the 20 years from 1875 to 1894. 1875 to 1894. In 20 years, the number of death is over 0 death, 1 death, 2 death, 3 death, 4 death. Frequency is 109, 65, 22, 3 and 1. Fit a Poisson distribution for calculate the expected frequency. We are to calculate Poisson distribution. So for first we are having the multiplication of fx, that is 0, that is 65, that is 45, that is 9 and that is 4. So 122 is over there and this is 200. So m is equal to x bar is equal to sigma fx upon sigma f, that is 122 upon 200, that is 0.61. So the very first we have calculated the m value is 0.61. So e raised to power minus m, that is e raised to power minus 0.61. If we will see the table value, we can having the direct table value of this, and we are having the second method of without table method, 0.6 to 1, that is 5434. 0.5434 the value. You can say this is e raised to power minus m, and I have having the underline of the value, that is 0.54. 0.6, the difference is 1, so 0.6 to 1 we will see that is 0.5434. We are having another method also for getting this, e raised to power minus m, that is reciprocal antilog 0.4343 multiplied by m. We can having this formula also. So the reciprocal antilog 0.4343 multiplied by 0.61. So we will having 0.4343 multiplied 0.61. So that is 0.2649. So this is reciprocal antilog 0.2649 is over there. So we will have a reciprocal. We will see the value of this in antilog table. So if we will see the antilog table for getting the value of this, that is 1841. We will see 0.26 to 4 and the difference is 9, so then 1841 is over there. So the value is for this 1841. For antilog table, how we can calculate or how we will see, the firstly we will get the antilog table, then we will see 0.26, the difference is 4, so that is 1837. 0.26 difference, that is 1837, and the difference for 9 for 0.26, that is 4, so that is 1481. You can see 0.26 here, the 0.26. So firstly we will see at the 4 and the difference is last one is 4. So with the help of this we will having 1 point, here the 0 is over there, so we are having 1.841 and the rest, and this will be 1.841, so we will get 0.5434. So with the help of this also we can calculate 0.5434, and we can having the table of e raised to power minus m, that is also we can calculate, that is 0.5434 is over there. Now for calculating estimated frequency for that, formula is px, that is and e raised to power minus m, m raised to power x factorial x. So we will write estimated frequency here. for Px is equal to 0. So there is 200 multiply 0.5434 multiply 0.61 raised to power 0 divided by the factorial 0. So there will be 200 multiply 0.5434 multiply 1 upon 1. So first is 0.5434 multiplied by 200. So the first is 108.68. 108.68, or we can have it 109. So the first is estimated frequency is 109. Second, x for 1, that is 200 multiply 0.5434 multiply 0.61 raised to power 1 upon factorial 1, that is 200 multiply 0.5434 multiply 0.61. 66.29, or we can write 66. So second value will be 66. For x is equal to 2, that is 200 multiply 0.5434 multiply 0.61 raised to power 2 upon factorial 2. So that will be 200 multiply 0.5434 multiply 0.61 raised to power 2 upon 2. So solution is 0.61 divided by 2, 20.21. So that is 20.21, we are having 20. For x is equal to 3, that is 200 multiply 0.5434 multiply 0.61 raised to power 3 upon factorial 3, that is 200 multiply 0.5434 multiply 0.61 raised to power 3 divided by factorial 3, that is 3 multiply 2 multiply 1. .11, that is 4. Now Px is equal to 4, that is 200 multiply 0.5434 multiply 0.61 raised to power 4 divided by factorial 4. So there 200 multiply 0.5434 multiply 0.61 raised to power 4 divided by 4 multiply 3 multiply 2 multiply 1 factorial 4. 4.11 multiply 0.61 divided by 4, 0.62, or having 1. So this also 200. So with the help of the Poisson distribution, we can calculate all the value related to the Poisson distribution. With the help of this, what we have done, firstly we have calculated fx value, that is 122, this is 0.61, e raised to power minus 0.61, that is 5434. So firstly we are having x is equal to 0, we are getting 108.68, 109. Then x is equal to 200 multiply this point m raised to power 1 upon factorial 1, then m raised to power 2 upon factorial 2, then m raised to power 3 upon factorial 3, and m raised to power 4 upon factorial 4. By calculating this, the calculator will be available in your examination. So with the help of the calculator, you can calculate. These are the estimated frequency for that, and this is the original frequency for that. If they want that, calculate the chi-square test, whether the frequency is right or wrong. So we can we can fit the chi-square test also in this. There is no problem. We are having F0 and Fe. F0 Fe, F0 minus Fe, that is 0, that is minus 1, that is plus 2, minus 1 and 0. F0 minus Fe raised to power 2, that is 0, 1, 4, 1, 0. F0 minus Fe raised to power 2 upon Fe, that is chi-square test. So that is 0. Second one, 1 divided by 66. 0.1515, 0.01515. 4 divided by 20, 0.2. 1 divided by 4, 0.25 and 0. So the chi-square value will be 0.4651. Degree of freedom, that is n minus 1, that is 5 minus 1 for 5% level. Table value. We will see table value of chi-square test for the 4 digit. We are having chi-square table also given in this, that is called chi-square table. So for difference of 4 in, that is 9.488. 9.488. 1, 2, 3, 4, 5. So 5 minus 1, that is 4. 9 point. Againly I have to see 9 point for chi-square test. Okay. So seeing the chi-square test, that is 9.488. Here the table value is greater than calculated value. 9.488 is greater than 0.4651. So H0 is truth. It means the data is original. There is no difference in the data. If H0 is failed, it means the data have some molestation is over there, some difference in the data is over there. So with the help of this Poisson distribution, we can calculate the estimated frequency H we have calculated in binomial distribution also. So I think with the help of this video, you may be learned how to calculate Poisson distribution. Thank you once again.